So this question here, there's a lot of ways you can do. So I'm going to show you two methods. Just watch until the end so you can learn both methods, okay? The first method, I'm going to use it by using tricky substitution. How you know tricky substitution? Look, in a tricky substitution, whenever I have a root, you see there's a root here. If you have a root and then you have a, let's say a can be any number, let's say a squared minus x squared. This is sine substitution if you have this format. And then you're going to say x, let x equal to a sine of angle or anything here, but I like to put angle. If it start, let's say for example somebody say now if we start with the x squared, because not all the time they're going to give like this, so this is sine substitution because number minus, I'll break this into x squared squared. If you have this format here, let's say x squared minus a squared, this is sec, so I'm going to say x, if we start with the x equal to a, and then I'll say sec theta. But if you have plus, let's say x squared plus a, or vice versa, because if you say 1 plus 2 is same as say 2 plus 1, and then this is the tan, so you say x equal to a tan of angle with no square. You see, with no square take a. So for this case we know we're going to use sine substitution, but before I say sine substitution, this is power 4 and you don't need power 4, it must be power 2. See, so I'm going to say first I'll break this. I'll say this is equal to integral of x, and then this is going to be 1 x squared and then square and then dx, and then after that I'm going to have to eliminate this. Okay, so I'm going to eliminate, I'll let this x squared equal to u equal to x squared, differentiate, this will be du equal, this is going to be 2x dx, 2x dx. See, and then look, x dx equal to du over 2, because I want to get x dx, so I'm going to say this is over 2. So I'm going to replace this x dx, so I'll say this will become, if I move x dx, will be du over 2, du over 2. So this 2 is going to go at the back, so I can just remove, let's say 1 over 2 is going to go to the back, and then this half here is going to be square root 1 minus what? X squared. What is x? X equal to u, so it's going to be u squared. So this same is say, you see, this same is say 1, okay, so then this is what we have. So when you have this, then we know this is sine substitution, so we can just stick to the sine substitution right now. So we say with the sine substitution we're going to let, so let's leave a half here outside and let's let, so we're going to let now u equal to 1, because this is like 1 square, 1 sine, so 1 sine is like a sine theta, so differentiate d, u equal to cos theta d theta. Also we can replace everything here. Okay, so this is going to be 1 over 2 integral 1 minus u squared. What is u squared? Sine squared. So it's going to be 1 minus sine squared square root, which is going to give us cos theta. But let's just show 1 minus sine squared, because you sine squared and then square root. What is du? du equal to cos theta d theta. But this equal to cos theta. When you get the answer in trigonometry, it's going to be equal to cos theta. So it's going to be a half integral of cos theta times cos theta, which is going to be cos square theta d theta. So now we can replace this using the tricky identity. Cos square theta, whenever you have an integral of cos square theta, you don't need square, cube most of the time. You can, especially when it's square, break it into tricky. So we're going to say we have a half integral, this same as say cos double angle plus 1 over 2, if you have to replace them. See? But how did I know? Let me just show you so that you can get to learn, because the important thing is to learn. That's what I'm here for. If somebody give you cos double angle, this same is say 2 cos square angle plus minus 1. See that? So now if I want to make a subject, cos square means this one is going to come over, so that's why I say this is going to be cos double angle plus 1 over this 2. This is going to give a cos square theta. See, that's why I have to replace this cos square theta with cos 2 theta plus 1 over 2, which is this one. 2 is going to go at the back, so 2 times 2 equals 4, so this is going to become 4, and then I can raise this. So that's what I have, and then I can separate my integral by saying this is going to be 1 over 4 bracket integral of cos 2 theta d theta. I can do quicker, right? But I'm just doing this for you to learn, okay? And then this is going to become plus integral of 1 theta, 1 d theta, just a d theta. And then This one is easy. What I'm going to say here is go to 1 over 4. 1 over 4. Okay, let's integrate. So first and foremost, it's going to be 1 over derivative of whatever is in front of the function of trig, which is going to be when you derive 2 theta, you get 2. And then when you integrate cos 2 theta, you get sine 2 theta. Okay, and then we plus, when you integrate d theta, you get theta. Okay, now the equation is done. So what we're going to do, we're going to have to, because the equation did not give us in terms of theta, theta sine. They give us in terms of x. So we have to bring back everything in terms of x. So if you come back here, can you see this careful? So first, I'll take it back to u and then u to x. So theta equal to sine inverse of u. So this let me say 1 over 4, and then this sine is going to become 1 over 2 sine 2. And what is theta? Theta equal to sine inverse of u, sine inverse of u. Inverse of u, and then we plus another theta, which is sine inverse of u. Sine inverse of u. Sine inverse of u. So then we're going to say, let's finish up. So this is going to become, we have 1 over 4, 1 over 4, right here, a little bit. 1 over 4, okay, 1 over 2, okay, now this is going to be 1 over 2 sine 2 sine inverse. But what is that u? Can come u equal to x squared. So I can say x squared, and then we plus. So this is for this. This is for this. Okay. You see what I'm saying? Okay. Now we say we plus. Sine inverse of u is going to be sine inverse. And what is our u? Our u we know. U equal to x squared. So I can say sine inverse of x squared. And then plus c. If you want, you can put this 1 over 4 inside. It's an option. So I can just put it inside. So this is going to become finally 1 over 8 if you want. Or if you don't want, you can leave like that. Say big bracket, this one plus a half, or you can leave like that. If you want, you can plug it in. This will be 1 over 80 sine 2 sine inverse of x squared with plus sine inverse of x squared, and then plus our constant c. So this is the first method. So now let me show you the second method. This is the first method, and I'll recommend do this first method. But let me show you another method. But I'll say all the time, and I'll recommend stick to this. Let's go to the second method. I'm gonna split that. So this is integral. So I have my x, and then 1 minus x power 4 is like x squared dx. And then, so I know I'm gonna add in 2. This is gonna be substitution of sine. Okay? Whenever you have, look, whenever you have a square root, 1 or a can be any number, minus x squared or function squared, then we know this substitution of the sine. So now we go, before I do that, I have to make it as a one letter. So I'm gonna let u equal to x squared, this one here. And then when you differentiate, this is going to give me du. When you differentiate here, it's going to give me 2x dx. You see that? So we have an x and dx, x and dx. So I don't need these 2. So divide by 2, divide by 2. So these 2 is going to come here. You see? So then I'm going to say I can eliminate. So this integral is going to become integral x dx equal to du over 2. So 1 over 2 is going to go to the back, and then it'll be left with the only du here. Du. Okay, let me just make a space here. Du. So that's what du. And then I'm going to have in my square root 1 minus u squared. So you see, this is a substitution integral of sine, because you have a square, it's like a 1 square minus whichever square. So 1 square is like a 1 square. So I'm going to let a substitution, I'll let u equal to 1 sine of angle. So 1 is like a 1 sine of angle. So I don't need 1, it's just sine of angle. Differentiate here, du equal, this is going to be cos of theta. When you differentiate sine, you get cos of theta, but what d theta. So let's replace everything. So then, this is going to become equal to a half integral, okay? I have my integral, 1. So I'll come back here, right? 1 over 2 square root 1 minus u squared. What is your u? U equal to sine theta. So it's going to become 1 minus sine theta squared. Okay, what is a du? Our du is equal to cos theta. Cos theta d theta. So 1 minus sine square theta square root equal to cos theta. So all this stuff here is going to be equal to cos theta. All this stuff here with the root equal to cos theta. So I can just replace, say, equal to 1 over 2 integral of cos theta. Times cos theta means cos theta square d theta. So this equal to 1 over 2 from the trig identity, cos square, equal to cos 2 theta. Okay, look, from the trig identity we know cos double angle equal to 2 cos square theta minus 1. So if I want to get cos theta, which you have to come and replace there, what is cos theta? Cos theta equal to cos double angle plus 1 over 2 equal to cos square theta. So I can replace this cos square theta with that. So I still have my half, and then this half here is going to come here. So I replace this with this. But these two is going to go behind. So it's going to make this 4. And right here I'm going to let you cos double angle. Cos double angle plus 1. Plus 1 bracket d theta. And the question is almost finished, right? So I'm going to say I can separate. So we can make a space here. And then I can say this MSA integral 1 over 4 is just 1 over 4. 1 over 4. 1 over 4. And then I'll say integral, let's do this. Integral 4 of cos 2 theta. Integral of cos 2 theta d theta. And then plus integral of 1 d theta is like a d theta. Because integral of 1 is just 1 times d theta d theta. So now we finished the question. The question is finished. So we're going to say here 1 over 4 equal, oh my god, excuse me guys, my pen is just embarrassing now. Okay, 1 over 4 over 4. Now differentiate this, you're going to say 1 over differentiative of, when you differentiate 2 theta you get 2. Write your 2 behind. And then when you integrate cos 2 theta, you get sine theta, sine 2 theta. And then with plus, this is going to give you theta. So the question is finished, but from the question, they did not give in terms of theta, they gave in terms of x. So first and foremost, I have to go back to u, and then after u, and then I have to go back to x. Now we go. So then I can simply write here, I can just say equal, let me use another pen. This equal to 1 over 4, 1 over 2, sine of 2 theta. What is sine of 2 theta? So we come here, look. Sine of 2 theta meaning is 2 sine theta cos theta from double angle. Sine of 2 theta double angle sine 2 sine theta cos theta and then plus our theta. See, but what is sine of theta? Sine of theta we know, okay? But a cos of theta we can get from here, cos of theta. There's a lot of ways you can do to get cos of theta. Look, how? So sine of theta we know equal to u. I can substitute, but what about cos of theta? It's easy. Look, if you have a triangle, let's say, okay, space, okay. You just make a space here, okay. If you have a triangle like here, I think you can see here. Okay, this sine equal to, let's say over 1. This will be opposite. What is the opposite? U, and this will be hypotenuse equal to 1. So this is adjacent, which is going to be 1 square minus u square. And what is the angle? Our angle equal to theta. So if you want to get cos, is easy because I'll say my cos angle equal adjacent over hypotenuse 1. So it's going to say the same thing because anything divided by 1 is that something. So cos of theta we know 1 minus u square. Okay, so I know my cos of theta, no sine of theta. And theta itself is sine inverse of u. So then I can simply say, so this is very, very crucial, this one here. So I can just simply say, I'm going to have to, okay, so I can just simply say, this is going to be 1 over 8, 1 over, or I can just leave 1 over 4, 1 over 8, whatever you prefer, okay, 1 over 8, okay, okay, this and this cancel, so just 1 over 4. 1 over 4, and then sine theta, what is sine of theta? U, times, this one here is square root of 1 minus u square, which we had it here. Square root of 4 to 1 minus u square, plus sine theta equal to sine inverse of u. Inverse of u. And then, now, still the question is not done because from the question they did not give in terms of u. They give us in terms of x, so I can replace. Whatever there's a u, I replace with the x squared. So here is going to be x squared. So this is going to become 1 over 4. And another thing, look, I forgot. Because when you multiply 1 over 4, this must be over 4. So this must be over 4 here. Must be over 4. So it's going to be 1 over 4. 1 over 4. U. What is u? U equal to x squared. So I'm going to say x squared. 1 minus u equal to x squared. X squared. And the plus sine inverse of x squared over 4. Sine inverse of x squared over 4. Everything over 4 because it's like a 1 over 4. Or if you don't want to do that, you can just say, you can write here prime. And then you can plus your constant. And that's the end of the equation. So, look, it's very interesting equation. It's easy equation. All you need to do, or what you need to remember is trig integration of substitution. For example, so if you have a squared minus x squared, then you know this is substitution of sine. How you do that? You say x equal to this number a sine of angle. But that's why I have to look it here. When I change it here, this is a is like a square number. Even if it could be, let's say 4. So for 4, I would say u, for example here, I'll say u equal to 4 squared, right? No, let's say 4. 4 means 2 squared. So this is like 2 squared. So then here, I could have said u equal to 2 sine of angle. So this is for sine. Okay, what about for tan? For tan, always plus. Either start with the x squared or a squared, doesn't matter, because when you say 1 plus 2 and 2 plus 1 is almost the same thing, so it doesn't matter. So for tan, what you do is say, okay, x equal to a tan of angle. So you need to remember those things. You see what I'm saying? So you need to know when it's plus tan. Okay, what happens if you start with the u or you start with the x? For example, if you, let's say we say x squared minus 16. So 16 means 4 squared. So you have to look this format. So this is sec. If you start with the variable minus number square, is a sec. So what we're going to do, let's say 64. So 64 means it's 8 square. 8 square. So I'm going to say x equal to 8 sec of angle, and then you continue. Then you derivate, you do your question. So this is how you solve this question. It's easy actually. See, all you need to do, like I say, remember your trig substitution. Those like if it's variable square minus number minus variable. So just easy like this. If you face time in this program, make sure you come subscribe, share this with a lot of people. Visit my website. You know, I have a lot of stuff on my website. You can purchase various products. You know, for women, I have a cosmetic, I have a underwear, bra, different sizes there. You know, the stuff has been made from overseas, some of them locally, you know, from Africa. So you have a variety of different type of stuff, okay? And for the brother too, I don't forget about you. I have a fitted cap, you know, shirts, hoods, yeah. So you got a lot of variety of things on my website. Tracksuit, but very soon I'm gonna come with the sneakers, okay? You know, quality. This stuff is quality, man. Like I say, some of them has been made from overseas, you know, from one of the biggest manufacturers. See, so support your boy. Some of them is made local. Most of them, see, because I'm one of the biggest, you know, I'm believing support local and make it take it to the globe. This is why I started this initiative. Why another thing, also have a program that I give back to the community, feeding the homeless, feeding people. So I have like a food program. You can check my video, you see, okay? Thanks a lot for your time. Subscribe and share this with a lot of people. Peace. I'll see you soon. You know I love you, that's why I do all this stuff from my heart, okay? Peace. I'll see you soon.